Oops.
Did you? That's fine. That's fine. That's okay. That's okay. That's okay.
We are almost ready, guys.
We're almost ready to go live, I think.
Well, let me set that up here. Okay, we're not showing the screen yet. I can log into StreamYard here. Oops, sorry. Hi, everyone.
Hello, chat. Where are we live? Are we live? Oh, look at that. It's also even the Mac cameras are now. We're getting the little thumbs up things.
All right, it is.
Where are we live, by the way? We are
on
twitch.tv/
AWS Made Easy.
Okay.
And okay, so now we've got the StreamYard Studio here.
Okay.
Allow mic cam access. There we go. We are on YouTube's AWS Made Easy. We are on Twitch's AWS Made Easy. We are on CloudFix LinkedIn.
Okay, all the places.
We are also on CloudFix Saves X.
Okay.
So we are there. Welcome, everyone, to our Tuesday afternoon live stream. It has been an incredible day in AI. We've had the Anthropic Claude launch, and everyone's been talking about that. So we thought, let's see.
What did we think?
I think if there is a perfect use for millions of CPU hours being trained, billions of invested, it's to get the right bit of code into one of these to replicate a stopwatch. What do you think?
I think there's no better use case of generative AI than to program for Arduinos. Check this out. We have these things. Look at us. Look at this camera setup here, my friends. So we're going to be trying to write some code for this. Some sort of a stopwatch.
Yes.
And I don't know. So, and we have Andrew Brown. Hey, Andrew, how are you doing, my friend? How to hook up an i386 machine to BedRock. Well,
it's way too powerful.
No, I don't think he's talking about specifically a 380. Well, are you talking about 386 or just the X not even x64, x32 Intel architecture? So if you're talking about the 32-bit system or i386, I don't know if I don't know if our CDKs work on a 32-bit system, but if they do, that's an option. But if they do not work on a 32-bit system, remember, a CDK is just an HTTP call. So if you can make a proper HTTP call, like this man and I did with
Lisp,
you can. So I don't know if we're going to be making calls to BedRock using an Arduino, at least not yet. But yes, also welcome to fun with Steve and Darko and the autofocus of this camera. Since we're not sitting so close to each other, our autofocus goes out of whack, just so you know, and we're perfectly aware of that. So, and Andrew, all the drama is welcome, just so you know, my friend.
Don't worry. Yeah, this is a Tuesday afternoon stream.
Exactly.
Pour yourself a gin and tonic and join in.
Okay.
For some fun. Let's try this. Oh, and so let's check out the camera views. So we've got
this
Darko
one.
And I, which you know, we've got the overhead view. So we've got our breadboard, we've got our display.
We have this fancy thing. Look at us. Look at us.
For simultaneous viewing. And then we've also got the code view.
I'm going to switch to that one. Let me see.
We've got BedRock right there.
Look at that. Look at that.
And we've got our Arduino IDE. So to outline the whole setup, this is a Mac Mini, 10-year-old Mac Mini that we're running BedRock on. So these 10-year-old Mac Minis, I get them because they're really cheap. They're like less than $150 on Amazon.
Yeah.
And I'm worried that I'm going to miswire this USB port one day and let the smoke out. And so I don't want to connect that to an expensive computer, just to be on the safe side.
I see a comment from Katie about my shirt. Do you like it? Is it great? Let me switch to the full screen. Look at this. Look at this. This is prime property. We got this as part of developer relations. My good friend and colleague Jen made this thing for us. So I hope we can give this to other folks as well at some point. But it is absolutely the best thing ever. So full of like these rhinestones and everything. So yeah,
it is really bright. I like it.
It is amazing. It is amazing. Okay. So let's Steve. I'm gonna have you move closer here, just because I want.
can
I want. Yeah,
focus.
exactly.
There we
I
go.
want you to be in the shot as well. It's not about my big bald head. It's about his big bald head.
Balding head.
Balding head, as we do.
Do the overhead. Why did we pick an overhead shot?
Exactly, because of the bald heads.
There we go.
Okay, let's switch to the. I guess. So tell me, Steve. What are we going to try to do today?
Okay, so here's the idea that we're going for. So this is a mock-up of a device that my kids and I put together. So you see, this is the original mock.
Mm-hmm.
And so it's in this box because I want it to live outside. This is going to be a stopwatch, basically. So I want to say who is logging in. So we have 6 buttons. Who is logging in, start, and stop.
Okay.
And so that was our original idea. So then here is our V2 of this prototype here. So we have V2 here.
Okay.
And this is going to have this segment display.
Okay.
And so the idea here is that I can say, okay, who is using the stopwatch? Okay, it's going to be me. So I push that'll be the Stephen button.
Okay.
And then I want to say start and have this be a timer. This is going to cycle and cycle and cycle, do a timer, and then I'm going to hit stop. And then what I want it to do is record that time and record all the metadata, who it was. So this was Stephen's time. Record the metadata and then send it over to, ideally, to AWS IoT Core.
Okay.
So this is the mock-up. So we've got an Arduino Uno R3. Now, obviously, we're going to use this breadboard setup for right now. Yep. So this whole setup just exists on the table. And the plan is I want this to be able to survive the weather. Once we get the circuits figured out, we'll get a custom PCB made, one of those JL PCBs.
Okay. Not sponsored.
Have a little battery pack.
Yeah.
Oh, but if they want to.
If they want to sponsor us, yeah.
Future sponsor.
PCB way, the best way to sponsor your YouTube creators.
Watching a lot of maker content.
Yeah, I know.
Right.
But Stephen, let me ask you a question. I'm going to bring up my phone here. So you're making this into a stopwatch.
Yes.
What about this? Isn't this kind of?
Yes, but I want this to be able to just sit outside.
Okay.
Like say if you're timing, say if I want to be able to sit outside,
okay,
use an 18650 battery.
Okay.
And so I'll have to have some little rubber flap with a
Charger.
USB-C rechargeable, or even learn how to do inductive charging and just be able to have this.
There you go.
So this case here has a hole here for this rubber gasket. So I've got a little rubber gasket. So this should be able to sit outside. These are waterproof buttons. I've got a little piece of plexiglass that I'm going to hot glue right in there and make this totally able to just sit outside in the weather for days on end.
Okay.
And why not?
Why not? Exactly.
But nothing says engineering like spending hundreds of dollars and 40s of hours
something
to save
that's an
app.
$2. Something that's an app.
On something that's already been invented 20 years ago.
I absolutely agree with you here. So I think that's a very fair statement. So let's do it. Ultimately, what we're trying to do is just build something with the Arduino here. We want to connect it to the cloud for, I guess you want to store your stopwatches.
I would love to have a dashboard to know, what's my time. Maybe I'm running laps around the driveway and I want to push this button every time I go a lap around the driveway. Why bother writing it down when I can have it uploaded to AWS IoT Core?
Okay.
Have it visualized maybe in QuickSight.
Okay. Why not? So the challenge for us right now is that we don't know how to work with this. I mean, we've written some Arduino code in the past, but I wouldn't know where to start. I would imagine we would have to get a bunch of button inputs. And I think we should first figure out how to do button inputs. Or do we want to first send the data to the cloud?
I think we should figure out how to get the button inputs.
Let's get the button inputs.
And I think we need to hook this up to get this display working. We don't need this button.
Okay.
So what do we need? We need, this will be our power.
Okay.
And this is hooked up to our Mac Mini.
Okay.
We've got the standard Arduino IDE. Let's get these guys out of the way. Okay, so we've got a few extra resistors.
So I'm gonna assume that this is a standard, 8x8 LED display.
Okay, so this thing is super cool. This is called the FC16.
Okay.
Now, as far as so this is where I learned how to use this, I used ChatGPT to get
Okay.
started with this.
Okay. So
And
you got to figure out how to connect it?
so I think so. So now I need to look at this code. Okay, so we want the CLK pin.
Can you just move that to the whole screen?
Yeah,
Or-
there we go. And let's
Awesome.
increase this font. Okay, so we want the CLK pin to be pin 52.
Okay, so that is this thing, and we need to connect it to a pin 52 on this one. Okay, Stephen.
Yeah.
This is getting complicated. Let me show you something. I need to
All
show
right.
you something. I'm gonna share my screen right now from my laptop. And I want you to see something. So you're gonna have to show it to people through StreamYard, like that. Let's talk about Vokvi or Wakwi, or I don't know how you pronounce this, but this thing is what we need. This thing is what all of the people who want to play with Arduino, ESP32s, and whatnot need.
All right, let's have a look.
So you can select yourself an Arduino, and you can just simulate whatever you want. So I'll bring this thing up, and you have your Arduino IDE on this side, and you have all of the hardware on this side, which means I can literally just add the buttons, add the displays, add whatever I want to my Arduino, and just simulate it, which is a really good thing. And it's so good that you can just literally select all, copy, and paste it into the IDE of the actual Arduino, and it will work on an actual Arduino.
Well, all right. Well, let's see if they have the FC16.
So let's do it.
So this is an Arduino Uno R3.
So let's see my projects. Can I just create new project? Let's do that. I'm gonna select an Arduino Mega. So this is a Mega one, right?
But no, this is an Arduino Uno R3. So
right, but we have a Mega here, right? This would be a Mega, a big size.
Oh, I forgot that. Oh yeah, right,
it's a Mega. So we select the Mega, right? Yes. And what we do here is, what's the name of the LED thing?
This is an FC16.
Oh, they don't have it. FC16.
Hold on. Let me double
LED. So you can do LED dot matrix 70.
Is it a 7219? Yeah, that's it. That's a 7219. So the arrangement, that's it. So the 7219, just so you can see on the camera here, is one of these modules.
Okay.
And now you see that they're connected in a series.
Yeah.
And so the way this works is the first one that gets connected in, it says, hey, I'm number 0 on this bus. And then the next one is offset, and then it passes the messages on, passes it on and on, and so forth. Okay, so
in this case, see, like, it's a little LED matrix, and what we can do here is we can just hook them up to a pin. So I would imagine we need let's try to work it here, and then unless you have the code ready on your side, but
I mean this worked the last time I used it.
Okay, so let's switch then. Let me hide my screen then, and then we can go back to the full screen. So, all right. So let's see. What do we have here?
Whoa!
What was that?
Oh, that is full screen StreamYard. Okay, I get it.
Okay.
Wow, that's weird.
Is this full screen StreamYard? No.
No, this. So let's make sure that we are.
Oh, okay. Yes.
So that's our infinite everything. Okay.
There we go. That's better. Okay.
So CLK pin is to pin 52.
Okay.
So
let me switch to this thing.
So let's just get rid of all the extra stuff. Start clean. Okay. 52 is.
Since it's the Arduino Mega, it has a lot more pins.
So blue is 52.
So what's the clock
CLK is right there.
Okay. CLK stands for clock, since it's setting a clock pulse.
CS is, what is it, carrier select?
Carrier select, yep.
And that is going to be 53.
Okay.
53 is currently purple.
Is it purple? Yeah.
Why do I make these things so small?
Because that's how you do stuff in electronics. You make it unimaginably small.
Okay, so this is blue, purple.
And by the way, for folks who have never worked with a breadboard before, this is how you usually prototype electronics. Use something like this, a breadboard, a bunch of cables, and then once you're actually ready to use stuff, you convert this into an actual PCB or printed circuit board. Now, the challenge for us is going to be not only the hardware, but also getting the correct software to display what we want, right? So we need to figure out how to, number one, display some text on the screen. Number two, react to the buttons. And number three, push the data to the cloud.
All right, so I've got this connected the way I thought it worked.
Okay.
So now let's.
Do you need? I think you need to connect power to it as well. I'm gonna go crazy and say that we need power. So because one of the things you will see here is that
ground.
Yes.
No, and VCC.
See, can this thing focus? Probably. There we go. So these two things. The first one is VCC, or that's the positive voltage. So that's going to be 5 volts in this case, and the ground. So let's do this. I'll plug in. We're going to need another one cable here. So I'm going to do ground here. The yellow is the green is the ground, and we're going to just plug it into.
So why don't we take the ground off of here? Do you want it into the breadboard?
Oh, we can do that. We can just. Well, do you have power into the breadboard, or? Well, actually, no. Let's do this. So, ground.
Let's take off the accessories here.
Okay.
A clean slate.
So we need. This is going to be 5 volts. So we're going to attach 5 volts to the positive rail here, and then 5 volts into the Arduino because we're going to have the Arduino supply some voltage. Now, Arduino can provide voltage. It cannot handle a lot of current, so just be careful. If you're going to power a lot of LEDs, you're going to burn up your Arduino. And then we're going to take the black wire, put it into the ground here, and then add it to here, into the ground pin. Oops, that's not going to work.
A longer one?
No, I need a male cable. So, do you have more?
Yes, let me grab. I've got a handful.
Okay. Steve's going to go grab some while we do this.
Office is as organized as the Library of Congress.
Of course. In essence, what we've done right now is connected the positive 5 volts and ground into these two little rails. Or do you have ideally a longer black cable, which is male? Beautiful. Look at that. Yes. Just so we can have a bit more flexibility here. So we're going to be adding this and then this. Nice. So now this thing is kind of.
No, so we need to connect to that.
Yeah, we're going to connect this to the ground. So the ground pin from here goes into the ground here, and I'm going to need a positive. I want more female to male. I think
this one I had that.
Or I have one here which we can kind of reuse. Give me a second. I'm going to reshuffle this. The green is going to be the positive because that positive like so, and then we add one more here to the negative pin, to the ground pin, and so into the ground pin.
Cool. Okay, so
now we are connected.
Okay, so here is the reason why I connect this into an inexpensive computer, because
don't want to
blow it up, or just to short circuit the USB bus. Let's see what happens. We have plugged this in. Okay.
It's running. You may not see it, but there's a little LED here glowing here and here. So this thing by default shouldn't run unless you programmed it. Did you push the code to it?
Let's see. Let's do Arduino Mega 2560.
Wait, let me switch to the screen. Okay. Yeah.
Okay.
No program is selected for the Arduino Mega.
That's very strange.
Is it?
It's plugged in.
Okay. Okay. It's fine. It's connected. It can detect it. Why is there no? Can you just click the check mark? No. That's debug. We don't need to do debug. That's the thing. Okay.
Okay.
So that's going to compile.
And now let's upload the sketch.
Yeah. Can you zoom in slightly, just so we can see it? Yeah. Awesome. So it's now uploading. You can see. You don't see it. Oh, there was a flash. There we go. There was a couple of flashes. I mean, I'm not sure what your program is supposed to do.
Okay, well, that is a great point. Let's actually look at the program now. So this I copy-pasted from the example code from this library. But let's go back over to the... So with Arduino, again, I'm an Arduino newcomer. But with Arduino, we have a loop. Oh, so it was supposed to do Happy Valentine's as a scroll. But I don't think it ever got there. So why is that? I'm not 100% sure we've connected it correctly.
So yeah, let's double check the connections. I'm going to switch back to the camera here. Hello, friends. Not that camera, that camera.
I'm going to have a look at the loop.
51. So we're just double checking here. So Stephen, I'm going to unplug this. Can you tell me the pins once again?
Okay. We were supposed to do 51 to the clock, or sorry, 52 to clock.
A second, we can just double check. 52 to clock. 52 to clock. That is correct.
51 to data.
51.
Or MOSI.
To data. Yeah, that's okay. And then
53 to
CS.
CS.
That seems pretty okay. It could be the fact that it doesn't have enough power. That could be a thing. So remember, you are powering this thing through a keyboard.
No, I have had this working before.
Okay, you have.
Exact
Okay.
setup. So let's plug this back in and see if we can. Let's see. Now we want to turn on. I think we can use the serial. Well, let's try.
Hey, it works.
Oh, so that was my old program. Happy Valentine's.
Look at that.
Now,
It is very bright.
Valentine's is long gone. So let's update this message here to live stream.
Look at that. Look at that. Woo! Claps in the chat. Amazing. Look at that. I wish it was there was a better way to see this, but yeah, as you can see, it is.
This, well, here, let's do this.
Turn off the lights. Can you do?
Oh, that's the color balance.
Color balance. Look at that. Yes. Live stream. Look at that. I love it. I love it. Nice. Nice. Okay, cool. So that works. Let's have a look at the code. I think we should discuss a bit of the code because there's a specific magic. Hey, Jen, welcome to the show. I see Jen Junod is here. Hi, Jen.
Oh, hello.
Hi.
Thank you for being here.
Hi, Jen. Back to the code. Yes. So a couple of things that is important here. Arduinos are usually programmed in C. Now, what you're looking here, this is C, the language. The stuff the White House doesn't want you to write about. But you can see there's a bunch of stuff here. There's a bunch of functions here. When like in this case, anything that starts with a void is a function, right? Void 0-point set and void rows and void checkboard and all these things. These are just functions that are existing here, and they're not all of them being used. If I understand.
So these are a set of functions that came as part of the demo with this library. So actually, what I could look at there is. So what Arduino code, it's looking for a thing called loop.
A loop, yes.
A function called loop, and it's just going to run this over and over again in a loop. So let me make this one in classic program format. I'm going to make this loop old 2.
Okay.
And I'll make this loop.
Okay.
So now if I recompile this code, it's going to call all of these functions in a loop, and it's just going to go through a big exercise. And then let's upload this to the Arduino and see how this goes.
So we should get a bunch of stuff right now. There's graphics.
And now this is the 0-point set.
Okay. Look at that.
Now that's okay. Now it should be doing a rows exercise. I think this is still 0-point set.
Okay.
Oh no, that's checkerboard.
Checkerboard. Bullseye. Look at that. Look at that. I mean, it's a really nice little display here. You got a bouncing ball. It kind of shows you how you can go to things. Now, because of the libraries that exist for this, it's relatively easy to kind of implement this. It's not that super complicated. But in essence, what this library is doing is individually addressing each of these LEDs through the power of just I squared C. I would imagine this is I squared C.
This is SPI.
SPI. Okay, it's even SPI, right? So,
Is it? I'm pretty sure it's SPI. SPI hardware interface.
Yeah, okay, so he's using SPI. Nice. And what we're going to be using this in this case, at least what Stephen's going to be using, is to display a clock.
Yes.
So I think that is the most important thing we can do. My suggestion to you, Stephen, is let's completely delete everything that we need besides the scrolling text, because that's going to give us the ability to kind of just stay. We don't need the bounces and all those things, right?
Well,
let's
do this. Let's make a new sketch.
Right.
Because I want to keep some of this around because I'm going to forget.
Okay.
Now wait, there's no idea in terms of a new tab here? No. New tab.
Okay.
I'm going to call this simple clock.ino.
Okay.
Now let's take what we need.
You can just copy everything, and then we can just remove what we need. As they say, art is taking everything and removing what's unnecessary. So,
I like it. Okay. Well, I think we need the Max 72 header.
Okay, that's the library included here. There's a bunch of I think those are okay. These are just like some of the definitions, specifically when it comes to the pins. That's all good.
Let's keep scroll text. That's nice. But then 0 point set. That's kind of cool. Let's get rid of that.
I think we can remove most of these things, to be honest, because we're not going to be using anything. We're just going to be scrolling text, right? So you go to the loop function, or to the make sure you don't do the setup function. It goes right.
Whoa. Okay. This is why I use Emacs.
Hey.
Okay. Intensity.
Okay.
Get rid of intensity. Blinking.
Okay, remove that, and we can get from there. Blinking, scan limit. It's okay. These are all like demo stuff. Like these are just kind of showing the functionality of this thing. And you'll see a lot of complex things here, like controlling specific things, but we don't really care for that.
Scroll text.
Don't delete scroll text.
We want that.
No, we don't.
Okay, but we can get rid of transformation 2.
Yep.
And
are you left-handed?
No, but Jeff is left-handed, and so when I approached the computer, that's where it was.
He has his hand on the touchpad is using his left hand, which is freaking me out as a non-left-handed person. Okay, beautiful. So we have the setup here. The setup is basically just configuring stuff. To be honest, we don't have anything here in the setup, but we can just leave that as a loop, remove the this loop we don't need. Yeah, we can just remove all of those things. Yeah, nice.
Okay, so now we have our simple loop. Let's go. What should we call this now?
Arduino.
Claude 3. Uh-oh. Claude 3. Save. Now let's see if we can be working. Let's save this. Okay, so now we have a very small file. It is 77 lines.
Okay, compile and upload.
Verify this.
Okay, we have an issue.
New definition of MD Max MX. So why?
So
is this in the same project somehow, and it's not?
Could be. Yes, that's why.
Okay, so I did want to set up a new.
Okay, new project.
Okay. Oops, where'd the other one go?
Okay. Try to compile it.
I hope I didn't lose the other one.
No, it's there.
It's there. Okay. So let's call this simple clock. Okay, where are we? Simple clock. Okay, so now we're in a different project. It's simple clock. We've got scroll text. We've got setup. We've got a loop that should say Claude 3. Let's compile this.
Okay, so far so good. And then Seems to be good. Ta-da! Hey, Claude tree. It is stopping abruptly as soon as so as soon as the 3 finishes, it stops abruptly. But that's probably due to the fact how the scroll function is implemented. I mean, you can always do that, yeah. So what Stephen done right now is created a bunch of blank spaces. I mean, that fixes it, right? If it's stupid but it works, it is not stupid.
Claude 3. Now it should scroll all the way to enough.
Almost. Nice.
I'll be right
back. Okay. While Stephen is handling a couple of things here, I'm gonna go ahead and look at some code. So let's look at this thing here. So we have the scroll text here. Now, the way it works is that it has a char width. Basically, looks at the width of the string in itself because we're passing this whole thing. It prints. I would imagine this prints it into the screen or somewhere. I don't know. And then while this thing is size of, I wish there could be a way for us to kind of make this longer. I'm sure there is a way to do it. But yeah. Oh, Steven's back. Steve, welcome back.
Oh, good.
Okay, so let's figure out how to. I guess let's figure out how to display time on this one, right? I think that would be the approach right now, right?
Should we? Oops. Let's do our picture-in-picture.
Oh, this one?
Yes.
Okay.
There we are. Okay. Cool. Okay. So then if we're going to share the screen?
We can't.
I see it.
Right?
Okay.
So we're combining both StreamYard and an actual hardware video switcher here. So that's one of the challenges we have here. So this is a whole picture-in-picture deal here, thanks to Blackmagic. But if you want to share a screen, it has to be like this, right? It has to be full screen.
I think we could do picture-in-picture on that.
Technically,
doesn't matter.
Right. Technically, we could, but you need to set up a thing. Yeah.
All right. Okay, so let's have a look at the next. So I guess what is the next step?
I think we need to figure out how to let's display a clock on this. That's
yes.
what we need to do. Okay.
Yes.
So let's go back to the screen. We need to figure out how to display a clock on this thing. Now we can Google it, right? Or we can use Amazon BedRock.
So yes, here's where.
Can you make this full screen and zoom in a bit?
Yes, absolutely.
Okay, just zoom in once or twice. There we go. Okay, look at that. Awesome.
Let's go to.
By the way, folks in the chat, thank you for joining us on the stream. Let us know if the audio is fine because we have this weird kind of a multi-microphone setup here. I just want to make sure that both of us are equally as audible and it's not too bad. So, Stephen.
All right, so let's give this a try. Programming for let's see. I would like Arduino. Well, what do we want to do?
So I want to display a clock in Arduino. Let's first figure out how to display a clock in the serial console, right? I think that's the simplest approach. Instead of just asking it to do everything outright, let's see how we can display a clock in the serial console.
I would like to implement a stopwatch functionality in Arduino. Now, do we want? Let's see.
Let's just.
I would like to display a stopwatch in
the serial
seconds
console. Yeah.
in the serial console.
Yeah, and then once we have that data, we can easily put it to here. I don't think that's going to be a problem. So let's see.
Okay, now this is Claude 3 Sonnet, just released today. Millions of dollars of investment. Yes, and then BedRock, same moment. I saw Adam Slipsky tweeted out 6:55 a.m.
Yep.
Let's see if this is going to give us what we need.
I'm actually pretty happy with the way Claude 3 works. It is just so good. It's wonderful. By the way, it is producing this code really fast. Steven's computer is not that new, so it's kind of really slow when it comes to displaying these things, just because it's the browser is slow to refresh.
This is a 10-year-old Mac Mini.
Yeah.
But let's see what it gave us. So it gave us this. Okay, it gave us some variables: start time, current time is running equal false. Okay. So setup, we initialize the serial connection. Let's see. if serial available.
It even created commands to the serial thing. I like it. So what it does here, it checks if there's a serial connection connected to it, right? Because not always does this thing have a serial connection on it, right? So if there's a serial connection connected to the Arduino, perfect. It's going to read the serial connection. If you press the S, it's going to start the stopwatch. See, if command equal S, it's going to start the stopwatch. I like it.
All right. Well, what we should do then?
Let's copy all of it.
Let's copy all of it. Let's see. Let's get these variables here. Tab over, and
can you zoom into this a bit more as well?
Yes. Thank you. We can get rid of this for the time being, can't we?
Yeah, that's fine. So in the beginning, we can add a couple of things. Yeah.
Okay.
Nice.
So this gave us our start time, current time, and is running, which is set to false.
Mm-hmm.
And then when we use that command, so let's see if serial.available. So let's get everything in this loop. Whoa, too fast.
See? Nice. Okay. So just go into the loop.
Let's comment this out for now.
Yeah.
We might want to use it later.
Nice.
And so we see this.
You just need to configure the serial number. So in the serial, if you go to the setup function, so just scroll a bit up. No, scroll up in the setup function. Right. So okay, it's fine. It's serial begin at 57,600. That's okay. But we need to. It is looking if debug is set, but debug is probably not set. So if debug.
Debug 1.
Okay, that's fine. Okay, okay, good.
So let's compile this guy. Where we missed a closing bracket.
I think you have an extra closing bracket. There we go. Yes. Nice. Okay. So now if you upload it, nothing will change on this thing. Nothing will change. However, we're going to have the serial console there. So if you open up the serial console, I think it's Tools, Serial Monitor. Okay. So now it is waiting.
And now we started it at 57.
Yeah. So you have to switch to that size. I think that's going to be okay. So press S. I think you
send it a message.
Yeah. Enter. Okay. Okay. So it is doing something. It is counting the time. See, 1, 2, 3, 4. So the time is going up every.
Wow. Okay. So we're almost there.
We're almost there. Now we have this thing. Now we have to figure out how to actually do this right now. So in this case, it is printing the time in you can send S again. Stop.
Wait. Yeah. Oh no, it's P.
Sorry.
Let's try this out. P. And then we can R.
Okay.
So this gave us a real interface here.
Yeah, exactly. So we're using a serial interface here, but it's an interface, right? So technically this is good right now. So it works. See, and we have a stopwatch. Now we have to figure out how to get this data instead of a serial terminal to this old thing.
Yes. Okay. So then what we can do, we can either read documentation, all that stuff, or let's give this a shot. Here is my code.
It has it. Okay. Well,
because I'm giving it the merge code.
Okay.
Or actually, let's say I have integrated the code. I would like to display the time on the attached, what is it? Max 7219 display. Please modify the code below.
Okay, good.
Okay, and I've just pasted it in.
Okay.
Now temperature is at 1 right now, so we were maxed out on the
randomness,
and the creativity. We were giving this free range. Probably could do with temperature 0 if we wanted to.
Now the beauty about the Claude 3 in this case is that it has an insane context window. 300,000, I believe, tokens or something like that. 250,000 tokens.
Yeah, I think
so. It can get a lot of data into it just through the prompts. So that is really, really crazy.
Now,
okay,
I noticed one thing about this that is somewhat odd.
Mm-hmm.
It changed the pin settings.
Oh, did it? Oh, it did. Okay, well that's
Okay.
fine because it probably
fine.
found somewhere from somewhere else. It actually is using a different library, ledcontrol.ah. Okay.
Okay. Wild. Okay.
So serial shutdown. Okay, let's see the main function. Or the loop function. Okay, serial read is running. Really, serial pre stop what started. Okay. I wonder. Okay. So
Now, could I tell it to use the library that I already have?
probably.
Let's ND Max 72XX.
Yeah. Just tell it, hey, please just use this library.
Use the.
Okay.
And so now what it's doing, it has the context it already knows.
It's again change the panes, but that's fine. Remember, kids, I'll give you one piece of advice. Never trust the large language model blindly. Always check what code it is. And if you're not sure what the specific line of code does, ask it.
Well, luckily we didn't hook up the launch the missiles pin.
Okay, nice. So let's see what we have here.
What did it ask?
It's a bit more complicated. I feel like LED ones was a lot more simpler.
So mx.begin, mx.control. So what is the mx? Okay, so it created an instance of this mx object. Now this is interesting. It used the CLK pin, data pin, and
that's
CS
fine.
pin.
We can change that.
It changed that. Yeah. So let's have a look at our code. We need to. Do we have the MX? Yeah. So we have an MX object.
We do have an MX object,
and it's using the same variables.
Yep.
Well, not really variables, macros.
Constants.
Okay. So
that's okay.
We have this. This is okay. One thing that's interesting. Hardware type.
Yeah, CS pin, max devices. We do have a max devices defined somewhere. I think it's also max devices is 4, and the max devices is just the number of these little blocks, which is 4 in our case. Okay. So, all right, let's go back to
we have to. In our setup, let's initialize this and clear it.
Yep.
So let's copy this and put it into our setup.
Yep. The setup function only runs once during the start of the device. So as soon as our device starts, that's when the setup function is executed. So, okay. There we go. So you have another if not mx begin. You can remove that one. So this is just the same thing, but just mx begin. So this is if it's not successful. In this case, right, we get rid of, exactly. So we don't need error checking here. Nice. Okay, let's go to the other one. Now in the loop function, it is mostly the same.
But what it's added is, where has it added? Okay, it has.
It's at the bottom.
Else if mx.clear if running is running,
and then that's how it actually displays time. It has a function that displays time. So there's an additional function in the bottom, void display time. This is the one that actually displays the stuff on the screen. See, mx set chars. It defines it on the actual characters. So we have to copy the whole function here. So if you see the bottom function here,
so let's do
void display time. Yeah. So let's add that. Just add it to the bottom below the main function, I guess. Nice. Okay.
So now we see the whole thing here. Max device. So what does it do?
I think it's
it's reserving itself.
Yes.
Oh, yeah. Okay. Yeah. So it's trying to figure out on this device, exactly which screen to use, and now is running. I believe everything else looks the same, right? We have this whole command thing, reset.
It has an MX clear. It has an MX clear. Okay, so go back to our function. Look at the main loop. In the bottom here. This one, yes. Else if command R. So line 104.
Right here.
Yes. Let's add the MX clear. Just MX clear. Okay.
Now, why didn't that come up in our completion?
Because Arduino ID is.
Oh, there it is. Yeah, it does have it.
It could be better. Arduino ID, you need to be better.
Now we want to add this is running block.
I think we have an is running block, no?
Or no, we just need the display time.
Okay.
So let's go to display time. Now, see, we are doing diffs in our heads. We could just copy paste.
We could, but that's no fun. So, but okay, let's actually delete a bunch of the serial stuff we don't need. I mean, we can keep it there, but
let's see if this works.
Let's keep it. Yeah.
Okay.
So let's go back to the code. Let's see.
What happened here?
No matching
Set
function to
char.
call. MX set
Well,
char.
It
No matching
seems to
function.
think it's there.
So, okay, so it expected 2 arguments, 3 provided. So that's the problem. So it is set char, int long length.
I'm going to tell.
Okay, we can just ask Claude.
Hey, Claude, I got this error.
Please fix. I saw somebody, I love it. They ask something to a LLM and they say, solve this for me, no yapping. And it just gives you the result, no explanation or anything like that. So,
Okay, so it gave us a nice explanation. It's also bringing in a new library here.
is it?
Why is it bringing in SPI.h?
Oh, yeah, it uses SPI.h. Even in the original code, it also brings in SPI.h. I don't know why, but
SPI.h. Well, I suppose we could ask.
right. I mean, we can add SPI.h. Ask why is SPI.h used. Okay. Okay. I mean, fine.
It is generally considered good practice.
Include all. Okay. Yeah, that's fine.
Okay, so it's saying the max. This is going to import SPI.h anyway, but it's okay. So did it actually fix what we asked it to?
So let's see. It changed the calls here slightly. See, it has 2. Yeah, it still uses 3. Let's just copy and see it. Let's see what
Well,
happens.
no, this one is 1.
It's still the same thing, but it's kind of complicating a bit. But let's just do all of those things.
Okay, so this is the new one. It looks pretty similar.
Right. It is, but it doesn't have a module of 10. See, it doesn't have the module.
Oh, right here.
See, yeah.
Yeah.
Okay. Let's delete that. Okay. So no matching function to call. Let's see. I want to see can you open up the output? Just expand it. So let's go to the top. Let's try to debug. Void display time in function. No matching function to call the in file included. I feel
so
like
the first one. This is an int. That
yes.
should be an int. The second one.
Do we have max devices defined?
Now, why is this 0 plus?
I think it's because of the print. It's long unsigned int. I don't know.
Okay, I think max devices is correct. Max devices 4.
Okay.
That's correct.
Let's go back to the code we got from Claude. I have a feeling like we're missing something. If you go back, I mean, this looks decent, right? It's supposed to take what is it? What's the functions? So when
this is the problem, right? It's having a character plus a number. Now, is this a C thing or
I don't know.
What
if that works? Try it. Yeah.
Is it going to fail on that line?
It's going to fail on that line as well.
So, what is this second argument supposed to be? Set char.
It's going to be an unsigned integer. Let's see. Is there an example code? No. Of course, there's no example code. Library creators, please include example code, please.
Loaded character from the font data. Loaded character from the font table directly into the column.
So I'm feeling we missed something. Without SPA.h. Like, I'm sorry. Here you go. No SPA.h. So it still looks the same. So I see like this is all a bunch of the same thing.
Well, it's this guy. Okay, it's here. Yeah, this gave us the same thing. My threat
Right.
was very empty.
Yeah. But so scroll up. I want to see the code. Go to the just here. Okay. So I want to see the function, the bottom function, display time function. So it says go up. I want to see the whole thing. So unsigned long minutes. This thing. So this is the minutes. So this is the variable here, right? So that's what it's using here. So and then if we switch to the to this thing, unsigned long minutes, seconds. This all looks good. I am really interested. Why is this complaining?
Well, why don't we try and get mx.setChar to just display a fixed thing?
Because it has a true here. Like I don't know why is this thing a true. Like this should not exist. Why is this a true? Because the setChar takes only two arguments. It takes 2 arguments. It has 3. So let's remove.
Okay, so I'm going to fix this to be what it suggested.
Right.
Remove.
Remove.
Get rid of these trues at the end.
Let's just try one. Just try one and see where it takes us. Okay, see? Haha, that worked.
Okay, so get rid of the rest of them.
Yes.
Now let's see. Because this kind of makes sense what it's trying to do.
Yeah.
And passing in the truth.
Yeah.
Okay.
Boom. Okay.
Switch to overhead cam.
Let's see what happens here.
Oh boy.
So I probably not gonna display anything.
Well, we haven't started the stopwatch.
Okay, so if you do S.
Okay, we've got something.
We got something. It is like you can't see it here, but it is blinking.
So there are changes happening.
Yeah, I believe what's happening here. It's writing all of the characters in the same one. See, max device is -1. So move. Okay.
So let's stop this. P. Pause. Okay.
So something here. I think setChar. Let's look at the setChar. Ask Claude to explain you the setChar, MX setChar, or explain me this. Just explain me this.
Explain the call to mx.setChar. It seems. I'm just asking. I'm not going to try and bias it.
Can we? Sure. Okay. So it is. I don't know what the true is. It still keeps throwing through, but the buffer position to 0. Oh god. That's a lot of things. Okay.
This is. I feel like this Michael Scott. Like explain it like you would to a 6-year-old.
Explain. You can explain to me like I'm a high school student. Explain to me like I'm 15.
I'll say
12. God, this is gonna be
You're
funny.
being too generous.
Sure. Imagine you have a small set of boxes.
All right, let's see what happened. Max devices. Imagine you have a small set of boxes. Each module has 2 boxes. So we don't have a total of 8 boxes to work with.
Times 2, -1.
The last
box at the position 7. So I do think this is a thing here. I think ask it. Does this work with 4 devices? Does your code work with 4 devices? Whatever. Does this code work with 4? Or are you expecting 8? It's 4. Daisy chain. CPP.
I don't understand why the first. Oh, this is -1, -2,
Yeah.
-3,
Right.
-4.
Okay, so it's going to play with 0, 1, 2, 4. Right. That's how it's supposed to display. Right. But it's weird. It displays it only to the first one. Right. So max device is -1 times 2. So that's going to be 5. No, there's going to be 6. Right. And then it's going to be 6. And it's going to be 5, 4, 3, 2, 1. Right.
I'm just wondering, is there a higher level thing we could use for this? Was there a?
Well, set character should be good. To be honest, I mean, this is kind of like, this is even lower level. The example you have here, this is even lower level. Like, see, it doesn't even doesn't use, like, it uses set character. See, like, there's a set character.
Well, let's see if there's a set character.
Yeah, scroll on. Yeah, a bit more. There we go. So yeah,
2 times column size
-1. So 2 times column size is just I think, so it's 8 in here. So it's going to be 16 -1. It's
15 0.
Right. I think it calculates. What does it do here? I wonder. Like, I wonder why are we getting?
Now, set char is.
Ask it about set char. Explain to me the set char.
Is that turning on a pixel, or is this printing a character?
It's printing a character, specifically. Right.
Okay. Yeah, it's because it has to be.
Yeah.
How does the scroll text function work? Let's see the definition of it.
So it's not even like, it's setting the column instead of the char, so it's even more complicated.
Set column.
Mm-hmm. I'm sure the set char should be the appropriate way to do this, but we just need to figure out what's wrong. I mean, I'm sure it's just a simple thing. Like, remember, it gave us the wrong instructions. It included through for no reason. Or maybe it's dealing with a newer version of let's get car.
But this is interesting. So loaded something from the font buffers. This is how it picks the right thing to use.
Okay.
So this is saying, because I'm wondering why. So when it says set column char width, okay. So this is C buffer is what you pass in.
Yep.
Right. So if this is character pointer to, so it is getting, so if you give it like ABC, it's going to go through this loop once for A.
Yep.
Right. And then it's going to, what is this? What is the TSL? Transform shift left.
It's just moving the pixels, right? By 1. Which we don't need, right?
Wait, this prints. Okay, so that's the.
I don't know what.
So this is our.
It's a serial. Print. Yeah, it's nothing. So it's just a function.
So then, what is putting it on the screen?
Set column. Set column. Yep. So it's actually printing a part of the character. That's it, right? Because it's not printing the whole character; it's setting a part of the character. That's why you have the whole calculation here. Like this doesn't do anything for us because we're not gonna. I guess you're not gonna scroll the stopwatch.
No, I'm just curious but what put it on the screen initially? What moves it? Because I see the transform moves it. But what puts the?
It starts from nothing. It starts from nothing. It starts with a blank screen. Right?
Oh, okay.
Right. It starts just scrolling to the left.
Char width. Okay. The char width. This is going to be something like the amount of pixels wide it is.
Exactly. Yeah.
Okay.
And then it just goes through the whole char width, adds the pixel of each one of those. So yeah.
So let's try. Let's see. Well, why don't we try just getting set char to do one thing that we know?
That's wrong.
Where's the other one?
That one. Yep.
Should have named the most simple clock. So let's just comment this out for.
Okay.
So should the following work? mx dot set char load a character from the font data as a specific column.
Yeah.
So this is where it selects
the column. So now you define the column here. Like, so how much columns does it have, right? This thing has 4 devices.
No, but I thought this is it has an array that's the font, right? So this is saying select from the font.
No, it just loads the character from the font data, right? It knows
so
it's font data. So you just have to give it a column. So like if you do like 4 minus 2, 3, let's put 6. Just put 6. right?
And
then you put the character, right? Here it should be something like whatever, right? A, fine.
all right, so let's see what happens.
Yeah, close it. Yeah.
So we should get an A somewhere.
Right, let's see.
When we start the timer.
Yes. Upload. Stephen is uploading, as you can see. Now, if you start the thing, just hit S. That's, I guess, an A. But this is good. So this is the first character. So let's stop it. Let's change the 6 to an 18.
Okay, so I want to pause.
Doesn't matter. We're gonna change the 6 to an 18. Just so see if we can move this character. Let's see. All right. Okay. Start. Hit the S. See, we moved it, right? So the problem here is not the. We need to figure out how to do better positioning on this case. I think the max devices minus ones times 2 blah doesn't really work for us, right? Press S. Boom.
Interesting. Okay, so I've tried to put an X there.
It goes on column 0.
So what I really say if this is how many columns is this? 8. So if I did 8,
it should start on this one. It should be the first one. So this is column 0, and if 8, it should start here. I'm gonna assume. Look at that. Yes. So it's actually 8 plus 1, right? See how this works.
Yeah.
So
okay,
it's
so
8 plus
7.
1. Yeah, it's gonna be 7.
Okay.
So to put the character on the first one has to be 7. This has to be 15. This has to be 23, and this one has to be 31. Right?
Okay. So if we were to do,
we can just hard code it. Kind of.
Well, let's just for comparison's sake. Give me a second. I'm going to log on to my ChatGPT account.
Okay.
Or let's see. Let's ask a different model.
I don't think you're going to get a better response from Claude in this case. Oh, from any other model than a Claude.
No?
So
okay,
yeah.
Well then let's ask ChatGPT.
Yep.
So give me while we're oops.
Oh, you have to log in.
Yeah. Give me 1 second to pull up my password.
So while Stephen is logging in, the goal would be, and to be honest, like I don't know how this is going to work because I'm not sure because it's pulling the fonts from its library. So I'm not sure how much numbers can we fit on this thing. We can do 1, 2, 3, 4, I guess. Should be minutes. I think that should be fine, right? So if we put 0, 0, 0, 0, now we need to figure out if we can squeeze in like a column here in the middle, but I don't know how that's going to be done. We can just put a little dot potentially, but yeah. So this is going to be a thing we have to figure out. Okay, so Stephen is logged into his ChatGPT. You can close that one, I guess.
Okay.
You can close the side. Yeah.
Let's see.
Okay, switching to the screen.
Okay, so we're going to copy this in. Let's see. You know what? I'm just going to copy and paste the whole code.
Okay.
And I'm going to close that. Okay. So I want to say, fix the above code to make the display show a stopwatch. So I gave it very little. I pasted in the code.
It's still using the same.
But it's done something different.
Is it? It is not.
Let's have this. So just trying. Remember, we're trying to avoid thinking here.
It is the exact same code, but let's go for it.
Well, is it?
Yes.
Oh, you're right, Max. -2 times 2. No, that is character 0. 1, 2, 3.
Mm-hmm.
No, that is it uncommented the code.
It just uncommented the code. But I think the confusion here is it's the number of devices is 4, right? That is correct.
Yes.
But I do have a feeling somewhere something. I feel. Here's the thing. Listen to me. Hear me out. We have just done a bunch of diffs here.
Yes.
And if you scroll all the way up in this code, we have left a lot of stuff from the beginning, right? So hardware type, max devices, all of these things. If we go back to our code, and you go back to our code, if you go all the way to the top, we have a lot of print functions here, right? And debug functions, and prints and puts and all that stuff. So let's see if all of these things are here correct. We are using SPI. Scroll a bit down. So SPI hardware interface, hardware type, CS, max devices, that's all good. Delay time, I don't really know if we do any of those things. Scroll text, we don't really use scroll text at all, so it doesn't really matter. The only difference we have here between this and the actual code is the speed of the serial connection. At least that's what I think.
I think that there's nothing that's different. Well, I mean, I pasted this in and it uncommented these lines.
Yeah.
So just thinking this through logically, right? So max devices is 4. 4 minus 1 is 3. 3 times 2 is going to be 6, and it should stick a 0 there, right? So if we just did this, just give it one line.
Okay.
Actually, let's start with the seconds.
Yeah, remove 131. The line 131.
Yeah.
We don't need it.
So this is saying max devices is 4, minus 1 is 3, times 2 is 6, minus 4 is 2. This is going to be too far over, right?
No, it's going to be just too close to the thing. It's going to be 6, right?
See, we kind of want this all the way.
No, it's fine. It's fine. It's going to be here. That's okay, right?
All right, so let's try this. So if this is seconds, this should increment. We should see this incrementing.
Okay, let's flip into this one. Okay, uploading. And now Stephen is going to hit the S button. Okay, S. Okay, it is incrementing.
Look at that.
It is working. So we are getting a countdown, a timer here, but we need to shift it a bit more. So the positioning here is the challenge.
So I would shoot. Well, let's see. If we did this to -2.
Okay.
Right, that's going to, well.
It's going to move it 2 pixels.
Top?
It's going to move it 2 pixels to the side.
So we want to move this a lot further over.
Well, no. So this is the timer. This is how it's going to be 0, 0, 0, 0.
Okay,
right?
gotcha. Yeah.
So
this is the rightmost.
Yeah, this is the rightmost thing. So,
okay, so if we do this to 2,
let's see. So we're moving it slightly. So we're going to move it a couple of pixels to the side. I mean that's going to be the solution. We need to just adjust it.
There we go.
0. Look at that. Beautiful. So that works.
So now let's just systematically uncomment this.
Yes.
Now, if we're going to say this is going to be the tens place.
Yes.
Now we want to move this over to the left. Let's just get rid of this -3.
Okay. We're going to have to add more. We're not going to have. We're going to
do +1.
+1. I think we're going to have to plus more. So what's yeah, okay. So we need to add at least 8 pixels between them. So this is gonna mesh.
Oh, I see. Oh, I see. Yeah.
Right.
Okay. Let's just see it.
Not mesh. I think we need to add 5 or 6
overlap,
pixels,
right? Because the width of the font. Oh,
See?
there they are.
Yeah.
Yep.
So the width of the font is 5
So if we
pixels.
did a +2, right?
We need to plot anything. You do +3.
And then so this is going to be +3.
Yeah, at least, or +4. But let's see.
And then what do we do? This is going to be dumb.
+8.
+8. Now we could have some character count. And
Right. Yeah, we can do this much smarter. But let's make it work, make it good, make it pretty. That's how it works.
Okay, here goes. Ready?
Hey. Okay, we still need to move the second character slightly. So it's going to be +4, I'm going to say. Yeah, +4 or +5, I will see. But I think that's going to make it look nice.
Wow. Okay, that's very spread out. Let's do +4.
Is it spread out? Am I crazy?
Let's be economical with our pixels.
I mean, fine. But this is good, but it's kind of connected. I feel like +4.
Oh, no, the number. Yep. Oh, I see. Yep.
See?
You're right. Okay. What's going to happen here? Oh, I need to start.
Yes. See, this looks okay.
Okay, so now let's get the minute. Let's just say plus 8, add another more. We say 15?
Yep.
No, we can do 12.
12, yeah. 12, yes. I think this is going to work. The thing is, the middle character, the column is going to be just fine. It's a small fixed character, so it shouldn't take a lot of space. So we can tweak that, right? See, we need to add more. I think 15 should be fine. Yep. The reason you don't see it here, but it is actually blinking. The reason you don't see it blinking, the reason it's blinking is because this thing does not have enough power to supply it, but that's fine.
Is that what it is? Is it?
I would imagine so. It's very bright, so we can reduce the brightness. As you can see, you don't see it, but it's
Oh
blinking,
yeah,
so-
interesting.
See,
Okay.
but it is a blinking a little bit. But that's fine. That's something we can fix. So,
Hey, look at that.
look at that. Yeah.
And why would you ever use your iPhone app?
Whatever. However, I do think, depending on the step, this is not a good stopwatch because it's only counting seconds. You should potentially count milliseconds, I would imagine, right?
I'm happy with.
You're
seconds.
happy with this? Okay. Okay, that's
Well,
good.
I do have another one of these displays.
Sure.
We could hook,
Hook that
but
up.
then I would have to re-engineer the box.
Yeah. Okay, so now we have this. We can add another minute here, which I think we should. The top level minute, right? So, because I don't know how long you're
Well,
gonna be, or is this sufficient? For
I think this is sufficient.
Okay, good. So we have the code. We have the code that does this, as you can see
Like,
here.
if this was timing how long I could do push-ups.
Exactly, and that thing brings us to this, which is glorious, awesome. And thanks to our friend Claude and ChatGPT, we've kind of gotten to where we want to go. Now,
So it was interesting. It wasn't perfectly hands-off, automated, copy-paste.
No. And I think that's also a very important point to understand here is that you can't just let it do its thing, right? You can't just tell it what you want and it's going to give you an exact thing you want. You need to push it. You need to tweak it, and meaning that your job is safe, fellow developer.
This is for a very, very straightforward application, right? This is literally a stopwatch.
Literally a stopwatch. Yeah, exactly. So yeah. So it does require a bit more kind of tweaking and working with it. So that's really good. Awesome. So do we want to do something more? Do we want to add something to it? Do you want to do a detect a button?
Should we? Oh, okay. So then, should we hook up physical buttons?
Yes.
That is the next.
Let's hook up a physical button to this thing. I think that would be a good case. We have one button here, just a single button here. Or you want to play with this little push button?
Well, I think that one's easier. I should have ordered more breadboard buttons.
Yeah.
Now, have you worked with button debouncing?
Yes, there's a way to properly debounce buttons. Actually, you have to hardware debounce them with a capacitor. You can deal with it in this case.
Well, there is debouncing library, but we've got pull-up resistors.
Or you can do that. Yes, exactly. So we can start with this one, right? I guess we can connect with that one. So let's figure out how to connect this first, I guess.
All right. Well, let's go back to Claude. We went to ChatGPT for a little bit. Let's go back to Claude.
Okay.
Now, is it going to? Did I save my context?
Well, you're doing that. I'm gonna. Oh, we have it here. Okay, we have it here. Okay, good.
All right. So let's try this in Claude. We are going to say
that's also one of the things about the chat playground on BedRock is that it doesn't save anything. It's not meant to be saved, so it's just a playground. So yeah.
So I'm going to do this. I have the following Arduino code. Please add. Now, is this we're going to use a please add code
that will
start the timer via a physical button press
on the breadboard. I mean,
the Arduino is a Mega R3. Also, tell me how to connect the button to the Arduino.
I love this.
Which pins should I use?
Do you have more buttons, by the way, or is this?
That's the only one like that I have. But we've got these, and I've got a soldering iron.
Okay.
We can make those work.
Okay.
Let's hit run.
Nice.
And if we're gonna do on-stream soldering, that would be. Why not?
Okay.
This is truly low level.
I wonder. I mean, this is. I mean, Claude can actually generate. It cannot generate images, but it can work with images. It would be really good if it could kind of show you on a picture how to do it. Connect the terminal of one button to the ground pin of the Arduino. Connect the other terminal to the digital pin of 2 of the Arduino. So, how do the buttons work here? Like on this thing, is it just each side? Is that how it works? I forgot.
So, let's see. There is you connecting the top row to the bottom row when you push the button.
What's the top row? This one, right? Okay, this one. Okay.
Yeah.
So I don't think you've plugged it in correctly. Did you plug it in correctly?
You can have it span the gulf.
Okay.
So
Yes.
if we do Arduino button circuit.
Okay. I'm gonna connect this to the ground, and I'm gonna connect another one here to the digital pin 2.
So here's the circuit that we're trying to emulate, digital pin.
Okay. Good. That's good. That's what.
But it's going to then complain at us, and we're going to try to then add a resistor into the circuit.
Okay, where does the resistor go? It's a pull-up resistor like that. Okay, so I see. Okay, so we have another 5 volts. We can fix that right now. So we need 5 volts between the bottom leg. So like this, I'm going to add a little resistor here. So between the bottom leg, like that.
Now for the audience, I'm going to put in, here we go. This is what we're looking at now. This is the Arduino push button tutorial.
Yes. Beautiful, beautiful. I think we have connected it correctly right now. So at least this looks fine from my perspective. And we are getting some stuff to pin number 2. So this should now work. Well, physically it should work.
Okay.
Now we need to go back to the code and actually see what we need to do here. So let's have a look at the code.
So this is what it gave us. Okay, so it has given us
Let's
pin. So define the pin for the button pin 2.
Okay.
Now pin mode. So you want to set it
pull
to
up.
input pull up.
Okay.
So what is a pull up? What is this? Do you know what's happening kind of physically?
No. Explain to me.
Well, okay. As far as I understand, like, as the switch is closing, right, there's going to be a bunch of noise.
Yes.
And so the resistor is somehow like smoothing out that noise, right? So because as it's getting closer, you can, whether it's detecting a button being pressed or not.
Okay.
I think that's what ends up happening.
Okay.
And so there's this, by using a resistor, you are, I think that there's like a threshold that has to cross before they say, okay, is it now?
Okay.
Okay. So then this is in the setup where we set this pin mode. Okay. So let's start this button pin here. And let's copy this into our IDE. Hey, we haven't got an integer overflow yet.
We haven't, no. I mean, it should be able to run pretty much, right? Okay.
All right. So we've got button pin. Now,
although I would say that this should potentially be defined, but that's fine. We can live with that right now. So
now let's set the pin mode.
It's in the setup function.
Yes.
There we go. Okay.
Now, digital read button equals low.
Okay, we're going to be changing the loop from the serial part to just doing stuff like that. We can just kind of copy bits of it, I guess.
So is this whole thing in the loop? If digital read
is low,
the
timer hasn't started yet. If timer started,
so this is like a one-way button. Once you
let's see what happens.
Okay, so let's add this in.
Okay. I don't think we're gonna be. I think we're gonna be replacing a bunch of stuff here. So if you here, okay. So
is it? Did it get rid of all of our serial?
So it's gonna complete. Yeah, it's not gonna control this. It's not gonna be using serial at all. So okay. So let's go back to the code. Just delete. I think we can delete the whole. Well, most of the main function.
Let's see what goes in there. Okay. So if digital read button pin equals low. Okay. So pull. So is the resistor going to register high?
Yeah, it's register high. It's pulling. It's a pull-up resistor, so it's high. Once we press it, it's going to be low. So
okay. So then where do we want this?
So no, it's here. It's here. That's fine. That's fine.
Okay.
Yep. If you go back to the code, to Claude.
Oh.
Go back to Claude just to see what we had. Yeah. So scrolling down, and this is the timer starter. So as you can see, it's going to completely remove the serial part, right? So it doesn't have anything. It's not. We can't restart it or anything like that. So just copy that bottom piece of code. If time started, that's it. Boom, boom. Nice. Copy it underneath this function. Boom, and I think the rest we can delete. So
Okay, so we don't have our
No,
serial
we're going to
interface
completely
to
remove that. Yeah. If is running, delete that as well. I think we only have to do remain the display time, but
Let's see.
So
let's see if we
delete that. Yeah,
we
that's
get
we
rid
don't
of
need that. Yeah, we don't need that.
that.
Perfect. So it is. Let's see. Okay, see, time started.
Now, does this start is running? We should set is running to be true. Oh, see that? So
It is complete. It has different things. It has changed your code completely because
yeah.
we started a new session, so it didn't just modify your existing code.
But I gave it the. Oh wait, did I give it the code before?
No.
Oh no, I didn't give it the code.
Yeah.
I thought I did. I must have not hit paste.
That's
okay,
fine. That's fine. We can change. That's fine. That's fine. If you scroll a bit down, we can modify this code to work for us. So if time started, that's fine.
Let's see. Do we have? Where's our setup? Do we have a setup with a? No, this is just outside of the whole thing.
Yeah.
So we have is running.
Right. And probably it has timer started.
Yeah. Okay. So let's just.
What you can do is running. Yeah.
So that's going to be starts to false.
Right.
And so if you
Is
push
running.
the button, or say is running. So it comes in as false. So not is running is true. Right. And then it starts time in milliseconds. And this is going to be is running. If it is running,
yep.
Which is going to be true. So if
Right.
you hit that, set it into true.
Right.
So otherwise, so before you push the button, it's going to say, okay, there's no digital read. So it's going to skip this part. It's not running. So it's going to skip this part. And then we can.
I think we need to just we can remove that function and just use the bottom one. So
I guess we need to calculate. Oh, this one.
Yeah, just remove that. I think that should be fine.
Okay, so just to go over the flow of the code. As we go into here, we're not going to scroll Claude 3. We're going to check: has the button been pressed?
Yep.
No, so it'll skip it. And then the second, once we push the button, it's going to, the next time it goes to the loop, it's going to hit this. It's going to say, oh, it's not running. So it's going to set running to true, and then it's going to exit this, and it's going to go into is running, where it will cut the timer. Okay, that sounds good.
Let's see.
Verify it compiled. Let's run it. So now we were losing our serial interface. Let's see what happens. Okay, so it's reset, and nothing's happened.
I think.
Whoa!
Hey, look at that! Now, there's no way for us to stop it.
No,
it's just going to get
irreversible button.
So we would need another button here. We can technically use one of these to kind of do the same thing.
But couldn't we?
What?
Couldn't we add a line here so we could say else?
The problem is you're going to have to hold the button. Oh, you mean like if it's running?
If it is running,
okay,
we can stop it from running. We can say is running gets false, and then do we end up? It's not going to update the display.
Yeah, exactly.
So it should just stay with the last thing it was.
Okay, let's try. I don't know. To be honest, I have no idea if this is going to work. So let's see.
All right, so it's going to.
Uploading, done uploading. Let's see. Boom, running. That's good. 1, 2, 3. Look at that.
What happened? Okay. So you push the button.
Push it again. Restarts.
Okay, so why is that? So when you push the button. Okay, so it's in this thing. Is running starts as false. So now once you push it, it's true.
True. So it constantly keeps checking if the button is being pushed, right? So the loop just goes around and around, keeps checking if the button is pushed. And if the button is pushed, then it checks if the is running is set to true. If it is true, perfect. It sets to false. It just stops it.
But then it skips.
It doesn't run that at all, right? So it restarts it. The next time we push it, well, it's weird. Like,
no, I think that when you pushed it, it stops it.
Yeah.
But then is it reading the same push, like a debounce?
Could be.
Could
be a debounce.
If you sleep here for a half second, I wonder how do I sleep
Sleep.
in Arduino? I hope it knows what I mean.
The delay function. You can use a delay.
So if I delay for a second, okay. So if I say delay 1000,
Okay.
so that should give you enough time.
Let's see. Are we ready?
Is that it?
Yes.
I
Okay.
think we're ready. Okay.
I don't know. Is it 1,000 milliseconds?
Yes. Is it too many?
Oh no, it's just uploading right now. Wait a second.
Oh, yeah, that was my fault. Okay. Huh.
Is it? Are you sure it's milliseconds?
I hope so. Delay.
Milliseconds, yeah. I mean, that's a lot of milliseconds. I mean, we're not doing anything. Press it again. Nothing. But yeah, why does it restart? Like that's now I'm interested to see why does this thing restart?
So every time you push that,
It restarts it. See, like we see that you don't see the terminal every time I push the button. See the whole thing just kind of pops up.
so
Maybe okay, let's do this. Let's remove the delay and add a serial print. Just prints. Just you can put it on the top, right? Just to see does it detect a single button push. So just do prints, capital prints, capital prints. It's one of the functions we have in the code. Just prints, just capital all capital letters, right?
got it.
It prints is just a little function we have defined as a constant. Yeah, and then just say button pressed. And just compile and see where it takes us.
I forgot a semicolon. This isn't Python.
It's not Python. Okay. All right. Uploading. Okay.
Okay.
So
now let's have a look. Let's see what happens. So we're pushing the button.
open the serial monitor, please. Yes. Thank you. Oh,
Wow. So let's see how many button presses we're
Yeah.
getting.
Yeah. So if you see this, boom, there's a lot of button presses. See, that is debouncing. That is absolutely debouncing the circuit because it detects plenty of buttons when I do this. If I hold this, see all of those things? Yeah, that's not fun. So that's the reason it kind of restarts it. Basically, what happens there, if I do this, it kind of restarts the whole thing because there's a bunch of button presses. I mean, it works for us. That's okay, right? In this case, this works for us for what we wanted to do. So anytime I press a button, it's going to restart the stopwatch.
Interesting. So how do we do stop?
We need to have a second button. That would be a better way to do it, or something like that. I don't know. Or
we debug this.
Or just figure out
the
the
hardware is
debug.
going to have a second button.
True. Well, is the second button going to be a stop? Yeah, I guess
Yeah.
so, right? So what you can do here, we can add a button here to the negative thing here, and we can add it to pin number 3. Come on, pin number 3. So now,
okay. So I'm going to delete this else block. We don't want
you
to.
can remove that. Yes.
Okay. So I'm going to save.
Save. Now
and I'm going to Control A, Control C.
Okay.
Right.
Okay.
And I'm going to clean up this playground. Let's clean this up.
Okay.
And I'm going to say, I have. Okay. Modify the Arduino code. I have added a button on digital pin 3. Make it function as a stop button. And then I've pasted in the code below it.
Okay. Did you paste the code?
Yes, I checked this time.
Okay. I don't.
What is that?
I don't think you pasted the code.
I did.
Can you go up? I don't think you did. You didn't. There's no code there.
Oh, there, right up there.
Okay.
I'll say
Modify my code.
modify the code to add a stop button on digital pin 3. Run. Okay, that looks like our familiar code. Okay, so we have a stop button pin. Let's have a look at what it did.
Is running equals not just false? Okay, fine. But it didn't do it correctly. I don't like it. I don't like the what they did here, because again, it didn't.
Because otherwise, this stop button is going to be a start button, right? If you can, we want stop button to say is running. It's false.
Right.
Modify the code to make the stop button only act as stop. If I push stop when it is already stopped, do nothing.
I have a very suspicious feeling it did not take your code into account, because it doesn't even show like the printing of anything. Like it just doesn't show the display like at all. That's ChatGPT.
Okay, I'm going to turn on ChatGPT 4. Okay. In the following code, modify, add a stop button on digital pin 3. Oh, do we need a resistor on that button?
We can. Yeah, I'll add it. You just do that. I'll find somewhere
The
scissors
stop
or little clips.
Button should only stop if the timer is not running. The stop button should do nothing. Okay. Oh, I didn't paste my code.
Okay. But I don't know. Can you debounce this switch as well? I guess you can.
Let's see. I'm just going to do a new chat.
How can you debounce these kind of buttons? Because it has only two pins.
It's still momentary, isn't it?
Right, but it has only 2 pins. The other one has 4 pins.
Oh, they're the top 2 and the bottom 2 are on the same are the same thing.
Okay.
Okay, so I've pasted my code into ChatGPT 4. Let's see what happens. Okay, here's how to add a stop button functionality. Here,
but this would.
Why don't we show our audience what you?
Yeah, but this would create a short circuit, wouldn't it? Am I crazy? So if I do this is connected to +5 now, and then if I add the negative, like connected to ground, wouldn't this create a short circuit? Am I crazy? I have no idea. We can try.
Let's have a look at what the.
Well,
hold on 1 second. Let me try one thing real quick while we're waiting. I do think we can do. Can you hit super source?
Hello.
What is camera 3? What is the
camera 3 is this one.
Oh, so now we're at camera 7. Okay, so now we've got a code. And then what is our lovely faces?
It's camera 3.
Okay, so camera 7 is there.
Yeah.
Camera 3. Oh, okay, there we go.
Okay.
So I can also switch it this way to camera 7.
Okay, that's ever easier for you, but
there we go. Okay. So let's try this. Okay, so this. Let's see what happens. Right when it hasn't blown up. Okay, so this says that we want to add another pin,
Yeah.
stop button pin. So let's do that. Where's our start button pin? Let's do stop button pin is 3.
Okay.
Now, where are we?
Initialize the puns, the pull-ups. Yep.
Now, it is being responsible in naming things consistently.
Yeah.
All right, so let's just do.
Okay. You have. By the way, you have to move your code because we can't see it.
Got it. Okay.
Just move your Arduino thing. Yeah, like that. There you
go. Okay. So, if we do stop button pin is input pull up. Now let's have a look at what we were advised to do here. Where's the stop button? So if digital read stop button pin is low, prints stop button pressed. Yep. If it's running, set is running to false.
Okay.
So we can just add that in our loop. Okay. So verify, upload. Okay, so this should reset.
Let's see. So now technically, if I press this button, we should get the timer started. That's pretty good. Okay. Now if this is pressed, oh no, we just get bumped intensity. Yeah, something's wrong. Again, I
think it was when it stopped.
It stopped it. Yeah. Oh, this one. Okay, this works.
Look at that. It resumed.
Okay. Stop. Hey. But you can see on the screen the serial printer. Stop button press, stop button press. So it does a lot because debouncing. There's no debouncing circuits. And then again, start. It goes. Stops. Goes. Stops. Goes. Nice. I like it.
Okay, this is
progressing.
This is good.
So a couple of things. We definitely need to figure out the debouncing circuit. I don't think this works properly because as you can see, a single button press has, I would say, a lot of button presses there. So yeah. Should I switch to the?
Oh yeah, switch to our.
To what?
There. Okay.
Yeah.
So, actually, I think we found what it was. Sorry.
No, it's fine. So basically, we need to figure out how to do proper debouncing here. Now, this doesn't work here. There's another thing in the code. So Stephen, if you switch to your code here, you see reset start time if you want to clear the stopwatch. One of the things we can do also, if you set start time to 0, it's going to reset the start time, right? So like
if we start it.
No, if you see line 107.
Yeah. 107 here. Still. Interesting.
Right. So we can uncomment that line, and that line now. What if we uncomment that line and run it again? So we're gonna get. Let's see. Basically, what's gonna happen here? Pressing the stop button, this big old red button, we're gonna reset the time. So this thing, fine, runs it. I can press it numerous times. Nothing happens here. I think nothing happens, right? But if I press this. It doesn't restart. Interesting.
What happened?
I was kind of hoping it doesn't restart the time. Have you compiled it and pushed it?
I thought so. Let me try it again. Compile and done compiling. It worked.
Upload. Okay.
Uploading.
Uploading.
Oh, done. Okay.
So this. Okay. It's running. 1, 2, 3. Stop. It doesn't set the start time to 0.
Start time equals 0.
So if I start it again, it starts from 4.
Do you know why? Because when you start time, if it not is running, no, it doesn't make sense to me.
No, it should like it looking at the code, this should work, right? So when you press the button, it should stop the thing, set the current time to whatever. To hold the total elapsed time, and then set the start time to 0. Right?
Current time, millis minus start time. But the elapsed time is only going up.
Right.
if it's running, start time at a 0. Update the display if the stopwatch is running. So when we hit start time, if we push that button, stop time is 0, and you hit start again.
Yeah, if I click start again, it's gonna continue.
It's gonna go here. It should update start time. So why do we change reset start time if you want to clear the stopwatch completely?
Right, this should technically reset the stopwatch. So if I do this, it should set the time to 0, right? But it doesn't. Right? If I press the button again, we're gonna see we're kicking off back from 26. See the serial print. If I stop 30, 32, boop, stopped, restart, still at 32. So it keeps the time. So the current times. If you uncomment the current time, comment out line 105. So this won't save the time, right? So if you do that, save, run, upload. Okay, start. This thing is running. 1, 2, 3. Boop. It paused. See, it paused. Okay, right, it works. Nice. Okay, that works. So we had to uncomment that line. So as you can see here, now I pause. It stopped. If I start again, it starts from 0.
Cool. Okay.
Nice. That's good.
Look at
Not
that.
sure if this is the functionality. You can go this in a couple of ways depending on how much buttons you have. But like, I would imagine you would start.
Okay, so now
start and stop.
So now once you've pressed the stop button,
Mm-hmm.
How do I calculate the elapsed time?
Well, you have the.
I want to save the elapsed time.
Well, you have the elapsed time. That's it, right?
But see, that's being declared only when I'm running. So I want to say at the time of the stop button.
Okay.
So I could move this elapsed time calculation
right
out of the loop.
I don't think you should, because if you move it out of the loop, it's going to constantly calculate the elapsed time. So
okay, so what I can do is I can also do this. Oops, nope. I want to say elapsed. I could just get this line. Before I kill start time,
okay.
do this. And I want to do prints. You stopped at. How do you print them? A variable.
I think plus. I don't even know, to be honest. I think it's that way, just plus and elapsed time. I don't know concatenation in C. It's been a while. You can do printf, but I don't know how this works. Yes, it doesn't work. Yeah.
Why don't I just do this?
Wait, there's okay. So serial print, you can just do that, right? You can just do serial print. You can see the example 117. Yeah, you can just do that. Yeah.
So this is going to be serial.print.
Right.
And then
you can just do you stopped at and
close that. And then this is getting ready because we're going to stick this into a JSON. Print line, and that way it'll give me a new line afterwards. So let's see if we can save that elapsed time.
Okay. So look at your monitor right now. So serial monitor.
Ready?
Start. This thing is running. If I stop this, I'm going to 4 seconds, 5 seconds, boop, 5932. Nice. So it gives you this big number because that's the exact number of millis.
Nice.
The way that it displays the time on the screen, 5 seconds, as you can see here, it does this. It does /1000, right? So it gives you the actual seconds. So yeah. That is pretty good. Now, if I start this again, I want to see what number you get. So it was 5. If I do 3, whoop. Yeah, that's good. So you see,
this is great.
Yep.
So now what I want to do is basically, so let's comment this code here. Now let's pretend that we're writing in Python for a second. Request dot post some server / stopwatch data.
Yeah.
JSON equals something like time : elapsed.
Yeah. Ultimately, the way you're going to do this is, my humble opinion, is going to be using something called MQTT. MQTT is a message server, message queue for super small devices. which you can just drop a message and something else will pick it up. So you won't post it to a server, you will post it to an MQTT queue,
I think we should be able to use IoT Core.
which is MQTT.
Okay, so let's Ooh, infinite scroll there. So let's go over to here and let's look up IoT Core.
Core, yep. So now, one question. Does this device have Wi-Fi?
No, but I've got a ESP8266 up there.
Okay.
So with a few cables and a bit of code, but you're right, that might be beyond.
So, but I do think there are Arduino Megas with Wi-Fi.
Yes.
So this one specifically does not have it, but your device needs to be able to talk to something. However, you could make it work with an ESP32. The challenge there is going to be you're going to have to send information to the ESP32 over serial connection, and then have the ESP32 uploaded to the internet. My humble advice: just get yourself an Arduino that does Wi-Fi, and be done with it.
I think that's
a
good idea. But let's just.
Yeah.
I'm curious to see if I even have. I believe I've gotten ESP32 in this.
Oh, interesting.
Giant hammer.
This looks like a 3D printed hammer. However, it's not.
No, that is a dead blow hammer.
A dead blow. What's a dead blow?
So when you hit it, it does not bounce back. Because if you hear it, it's got that little bit of a lead shot in it.
Okay. Wow.
And so it's good for hammering things that are on the more fragile side.
Okay.
Here we go. 5-piece ESP8266.
Okay. Nice. So one of these small little devices. Let's see how we can. Can you just move slightly so we can get some lights? So yeah, one of these.
I'm gonna go to the super source.
Yeah,
so see all of the faces too.
Super source. That's this one. This one. There we go. But you have to change the super source
to camera 3. There we are.
So one of these, which is can this focus? There we go.
There
Almost. We have a lot of stuff going on.
You know what? Let me give you a bit of light here, and then
maybe that's gonna help as well. There we go. We don't have to. Yeah.
Almost.
Come on. There you go. So yes, this one of these things. Focus. No, there you go. This thing has a Wi-Fi, and technically, you could have this thing work with an Arduino, right?
But then also, this is powerful enough to run this whole sketch.
Exactly. The only thing with this thing, it has a limited amount of digital inputs. So you would need an SPI. So you would need at least 1, 2, 3, 4, 3, 5, and for all of the buttons there, you need 4 extra. So you need 9 total. And this thing happens to have 1, 2, 3, 4. It has 8.
So it's plenty.
Well, you're missing 1.
Well, I think what you could do is if you use a digital input, you have a series of resistors. And then so you have a button in between each resistor in the series.
Okay.
And so you basically say you're looking for a voltage drop of a certain amount.
You can do that. You can also do it. The way you would have to measure the voltage on this side, and I'm not sure how to do that. I'm not sure if it can.
But I've seen a circuit for this. Let me see if I can find it.
Sure. There's bigger ESPs, by the way. This is a very, very small one. So
multiple buttons, 1 digital pin.
Yeah, exactly. Right. So that would work, right? But
so that's the idea. You have these resistors in series.
Yes.
So that when you push one of those buttons, then you have a voltage drop of a predictable amount.
Yeah. Again, the challenge here is just figuring out how to measure the voltage on this one, but that would technically work.
Oh, I see. And that's an analog input.
Yes,
because
this
that
one
way
has.
you can...
Yeah, that one. I don't know if this thing has an analog input. I believe it has a single analog input, A0. Yeah, it has an A0, which I do believe is an analog input. So this thing should have a single analog input, which should be enough, right? Ultimately, this thing should be sufficient enough for you to run this thing. Yeah.
So I do think that probably connecting this to this might be beyond what we're able to do right now.
Yeah, I mean, I wouldn't do it, to be honest.
We don't have the pins.
Well, I mean, yeah, you could. You can kind of do hodgepodge a bunch of stuff here. The challenge is you're going to have a very unreliable connection. The reason is you have to send serial data.
You send AT commands, right? Over that.
Literally just serial data. Yeah. I mean, you have to find a way how to parse serial data on this one, and also how to, there's communication pins. So you can send serial data from this one over to this one. Sorry, from this one over to this one, and then this one would have to read that serial data and post it on the internet.
So let's have a look.
Steve is just currently Googling or asking ChatGPT.
Let's see. I want to start a new session.
Okay. I'm going to switch to the screen.
What is the easiest way to connect ESP8266 to an Arduino so I can call a REST API from the Arduino?
Okay. VCC 3.3 volts. That's pretty good. TX and RX. Oh, you have the TX and RX. So that's how it would be. You need to do a voltage divider. You have to step it down from 5 volts to 3.3 volts. You could do that with an but you also have like voltage divider circuitry as well.
I think I've got. Oh, is this it? I think this steps down. But I don't know if this is actually going to work because that's when it stepped down 5 volts to 3 volts. But I don't think it's going to fix the communications.
Well, that's okay. I mean, you just need lower voltage, right? So it's a DC to DC converter. So this is a DC to DC converter, and it does. Sorry. Open this.
Let's have a look.
I don't see what voltage. I'm sure you can set that up, but oh, you have a plot level resistor here. I mean, I'm sure this can do bigger. To be honest, there's much smaller devices you can use, but I mean, ultimately this should work, right? If you can put in 5 volts and output 3.3, the reason is if you do anything more than 5, it's gonna fry it.
Yes.
Right. So.
There it is.
Yeah.
Okay, so zooming in a little bit.
Yeah.
Yeah. So this needs 3.3.
3.3.
This is coming out 5.
5.
So you can take this, put 5 in, adjust a tiny little screw right there,
Yep.
and get 3.3 out.
Exactly. Which is not, again, it's not beyond the capacities. Looking at the code you have on the ChatGPT, if you go back to it, you will see a bunch of serial commands here. So like it's going to be using the serial whatever library, and it's going to just talk to it through serial. So you see AT, just making sure, hey, are you there?
That's kind of cool. That's not that bad. Okay, so you set it as a Wi-Fi station.
Right, exactly. So, but basically this code is doing, it's actually having the Arduino set the ESP to whatever you want.
So the Arduino is configuring this.
Yes.
So this can act as a standalone device.
Right.
This little ESP8266.
Yes.
Which is, for I think I paid $11 for 5 of these things.
Yeah, exactly.
This can be its own standalone microcontroller, or it can act as a network card for a bigger microcontroller.
Network card.
Right. It can be a network device. But it's kind of cool. If you look at the code, it's actually it's abstracting away. I mean, for all that being said, right, to get this piece of hardware to talk to this piece of hardware, it's 3 lines sending it over a wire.
Exactly. It's a starting point. Now I wonder, this code seems like it's going to be running on the Arduino?
Yes.
Yes. Okay. Yes.
Right.
Okay.
So on the Arduino, you import software serial.h.
Yeah. And you can just do a couple of commands here. Again, it's just writing a bunch of stuff to the serial. Now, then at the same time, we would have to implement functionality on this whole thing to read the serial data and post it somewhere, right? Mm-hmm. Now, this is where the challenge also comes, is that how does it know it's good serial data, right? Is this all of it? Or like, what if it tries to send it in just like in the middle of a serial data being transmitted? So there's like a whole thing that we need to kind of be careful of to be able to do it, or have the Arduino to control the sending, right? So yeah.
Now looking at the code once, okay, wow. So you need to use AT commands.
AT commands, yeah.
To I see. There's a library like ESP8266 Wi-Fi.h that simplifies making HTTP requests. Let's see. Ensure your power supply is sufficient and stable. Okay. Do not power this directly from a 3.3 volt pin. Okay. Give me an example of using. Yep. So that's a little bit redundant.
ChatGPT is nothing if not redundant, so which is okay. Okay, so this example assumes you're programming it directly. So this is the actual programming on the ESP32. So this is not this is not the Arduino. So this is just ESP32, and this is just making a call, right? So in this case, this is very simple. It's just going to be connecting to an API. To be honest, it's not going to even do anything. It's just there's no loop. So yeah, this is just an example of how this should do. You should modify this code to kind of periodically read from the serial, whenever it receives a serial message, it should do something with it, right? Now, I don't know how that works. Like, there's no interrupts here or something like that. Like, there's a way for you to kind of react to it.
So interesting. So I guess you can define a little. You could program the ESP8266 directly, and define a little your own serial interface.
Yes. Yeah. Exactly. So again, it needs to listen on the serial part while the Arduino is sending stuff to it, and then once it receives a message, here's the thing: you can make this code like we did with the stopwatch of pressing S to do something. It can wait for a specific message from the Arduino. We can even put like a little string that's an end string, like end transmission or end time, whatever. And when it receives that, it should do something with the data it received.
Right. So then, okay, so I think we should. What are our concluding thoughts on programming Arduino using the latest and greatest sophisticated AI technologies?
Okay, my thoughts, and here's a hot take. You could not do this if you didn't understand this, at least a little bit. So you definitely have to have some existing knowledge of how do circuits work? What's the big deal with this? You also need to kind of understand the language slightly. Remember, we had to troubleshoot some of the code because we just got wrong code. So understanding the error that you get is critical. However, we didn't have to spend hours and hours going through the documentation or looking through Stack Overflow posts.
Overall, it was a lot faster than doing it by hand. But I agree, especially working out the math to get these to display in the right spots. That took a little bit of, really trial and error was the easiest way, which, I'm all for understanding the fundamentals, but trial and error
always helps.
It's a finite, the amount of mistakes you can make.
Exactly.
So I'm happy with this. I think for version 2 of Stopwatch
shenanigans,
I think what we could do is do the whole thing on this. So what I'll need to do is very, very, very carefully get those pins on here.
Yeah, that should be not too complicated. It's just soldering them on. So,
very tiny. I need to get one of those helping hands with the magnifying glass.
Yeah, this is it. To be honest, like this, I built keyboards, friends, and you usually use these for building keyboards. Well, similar to this. Just hold it like this, and then on your hands, grab it, get the first pin in, and that's it. And it just keeps holding. So,
all right. Well, we do have the soldering iron here, but I think this is enough for this stream. Yes. I think this In the future, though, it is pretty neat. We could do this, and then we could hopefully join this up to Amazon IoT Core, and then I can have my stopwatch.
Cloud-enabled stopwatch,
Cloud-enabled.
because why not?
Yes. All right. Well, thank you everyone for being here. It's been a really fun, great way to spend a Tuesday afternoon. Thank you for being here. Thank you for your chats, and really appreciate it. And Darko, thank you. This has been a pleasure.
Thank you, Stephen, for having me in the most amazing studio. Chat, stay cool.
Right.
Join us next time.
Bye, everyone.
Bye.